Okay, and Omar joined us. That's good. Okay. السلام عليكم ورحمة الله وبركاته. احنا النهاردة إن شاء الله هنبدأ أول حلقة في سلسلة Ask Quantum Industry أو Quantum Industry Series. Hello everyone. You are welcome to join the Quantum Industry Series or Ask Quantum Industry. إن شاء الله هيبقى معانا النهاردة دكتور طه سليم، باحث ومحاضر في جامعة أمستردام للعلوم التطبيقية والجنرال مانجر لشركة مولكت كوانتم ساس كومباني، وأيضا كوفاوندر لآي كافيه. ومعانا المهندس أحمد سليم، تكنيكال ليد في اي بي ام، وكمان اي بي ام كوانتم امباسادور. ازيك يا دكتور طه؟ ازيك يا باشمهندس احمد؟ ايه الاخبار؟
الحمد لله.
آه،
الحمد لله.
احنا النهارده ان شاء الله هنتكلم عن الريفليكشن اون اي بي ام كوانتم ساميت اللي حصل في هولندا في شهر نوفمبر. اعتقد دي كانت من ضمن الاي بي ام كوانتم تور في يوروب. فكنا عايزين نعرف كده من حضراتكم مبدئيا كده الساميت كان بيتكلم عن ايه، او يعني نوع المشاركات اللي حصلت في الساميت. ممكن نبدأ بدكتور باشمهندس أحمد سليم.
طيب، ألف شكر. Thank you Fergani for having me. I hope that my voice is clear and you can hear it carefully. And um, oh,
Yeah, we can hear you clear. Yeah.
okay. Sorry, there was a switch on the mic.
Okay.
Okay, so for IBM Quantum Summit, IBM selected some countries worldwide to do the Quantum Summit. We usually host it on United States, but recently IBM think to have in some countries just to spread the awareness and let people interact with the quantum team in IBM. So it was a good chance to meet a lot of colleagues, partners, clients in Netherlands. And really the summit was very helpful when it comes into the topics. It was very different from any other summit that I even attend before. We had the talks from the quantum hardware team, the Qiskit team. Even we listened to some IBM partners who joined IBM startup programs, and the startup programs that enable the companies to develop Qiskit functions and host it in IBM and to monetize it as well. And at the end, we highlighted the roadmap of IBM and the latest announcement about the latest processors that IBM announced in the Dev Summit in United States, Nightwalk and Loon. And each one has its own functionalities, so it's completely different. This is on high level. What are the topics? What we had on this summit?
Great. Thanks, Engineer Ahmed. Okay, Dr. Taha, what about you? Can you talk about the summit and
Yeah, it was very interesting time indeed. We also met with Ahmed there. We had fun together with our collaborators, Jan Blomert and Alain Chancey. We were present there, and what I like about the event, as Ahmed stated clearly, that IBM now is also expanding in Europe, but also in the Middle East and in the North African part. And this summit is sort of to gather all of this community in one place and exchange ideas about the quantum roadmap of IBM. IBM has very clear quantum roadmap towards the future. And they focus in this event first about what they have achieved with the quantum utility, which has been reached in 2023. like 2 years ago, and they have demonstrated also what you can do with a quantum utility. Like, okay, now you can use a quantum computer. There is some abstraction layers on it. You can call it. You don't need to be a very strong physicist to use it. There are some abstractions and some libraries that can help you. And they emphasized and amplified the message about achieving the quantum advantage and the definition of the quantum advantage. And there is pressure in the market indeed to achieve the quantum advantage and prove what you can do actually with a quantum computer. Because the quantum computer or the quantum technologies are still in infancy, so it's still young from the technology readiness level. So there is also pressure from the stakeholders and the market. If you have all of these massive investments, from like billions have been injected in the market, what do you expect, or when do you want you can see a quantum advantage? And for that, they showed clearly that next year, according to their roadmap in 2026, they are gonna show the first quantum advantage that you can do some useful computation, some practical computation that is not is infeasible to be done with a classical computer. Of course, the practicality here is a sort of relative, indeed, but that's a very good milestone. And how this will be a good transition towards a fault-tolerant quantum computer in 2029. That's a promise to have the first practical quantum computation when you have enough number of qubits and gates by this time. And they also emphasize their architecture, the kind of use cases they wanted to show, and also what could be the ideal use case for the roadmap. Like, okay, when I can use the quantum computer now and leverage the noisy hardware which is available, in which use case. So they emphasized this as well. Overall, it was a very nice experience because you get a lot of exchanges, a lot of collaborations happening here and there. And it's always nice to see how also some startups now are providing Qiskit functions, and which is a thing that we in Molkit startup, Molkit SaaS, which is based in Paris, we are trying to also produce in the near future for some of the use cases.
Okay, thank you, Dr. Taha. Actually, I have a question. Why IBM is always changing their roadmap? Uh, Actually, I think this question asked a lot, and we need to clarify this from you, Dr. Taha, and from Engineer Ahmed Salim also.
Maybe Ahmed can make a start.
Okay. Actually, the change, it might be in the positive or the negative, right? But I think changing the roadmap it's in the positive direction. Why is it we are doing that? If you look into IBM and the roadmap once announced, starting from 2016, the roadmap, I as far as I remember, for 5 years, then they redefined the roadmap again, revisited, and maybe they expanded to 10 years. Then now it's more than 10 years and above and beyond. Why this evolution on the roadmap? Because IBM is achieving a lot of breakthroughs in the quantum machine on different level. As you know, IBM, if you look into the roadmap, IBM is working in the full stack of the quantum machine, starting from the hardware up to the software and the abstraction layers and all the above. So if you look into all the breakthrough that IBM is achieving, so once they achieve a milestone, they are starting raising a bar because they see that we have a promising future. We did a lot of new discoveries. You will have a lot of publications in Archive and Nature magazine, which is a very prestigious, magazines in science. So all these discoveries help IBM to put like what we call it, I call it myself, aggressive plan, aggressive roadmap. And if you look into the roadmap starting from 2016 till the moment, IBM, they didn't miss a single milestone. Okay, so each year, by end of each year, we announce about, okay, we have this roadmap, these milestones, we achieved all these milestones on time. And this is why we are frequently keep changing, because whatever we achieve in the discoveries in the science that IBM is achieving in the labs, it's reflecting this on the roadmap. And another observation, if you look into IBM roadmap, you will find it into two categories. The one category for the research and the development, and the other one for the production. So once we have and achieved some progress on the development and the research, we will start reflecting this into the industry and the production level of the roadmap. That's why IBM keep changing or updating the milestones to more, as I can see, more aggressive milestones, ambitious milestones. They are raising a bar for all the quantum vendors to try to achieve the same.
Okay.
Yeah,
Actually, this kind of changing, yeah, this kind of changes in roadmap every year or for some period of time actually makes IBM more transparency about the quantum technology and the achievement they trying to reach. So now, Dr. Taha, please
yeah, and,
can you
we can
comment?
also, yeah, sure. And also, feel free to call me Taha directly, because, no point of this title. So now I wanted to add something is also the pressure of the market is really huge. I mean, you
Mhm.
have seen that IBM is now made a promise to deliver an advantage or to show within the modular design that they can deliver a quantum advantage next year. But then Google just made a very quick achievement. They have polished and enhanced its own chip, Willow, in order to perform verifiable quantum advantage. It's not a practical use case, but they can show that they can do with a very nice integration between the error correction and Willow chip. They can perform a computation that's very difficult to be performed on a classical computer. So there is market pressure, and this was a market pressure also drives the company, and IBM, of course, is very or like has an historical school in computing.
Mhm.
So they also wanted to stay on the top of the market, but IBM is using also one specific type of technology, which is a superconducting qubits. So the question is, okay, what you can do with this superconducting qubit? Can you do everything you want to do with a quantum computer, leveraging the superconducting qubits? I had an exchange with a CEO of one of the major companies in one of the public events 7 years ago, I believe, when I started a PhD, when I was in second year or so. And he, and also this is my belief as well, and the belief of many, that maybe one quantum hardware might not deliver everything promised from the quantum, and maybe you will end up having two double layer of hybrid integration. You can have like the classical quantum, but then within the quantum you can have maybe several types of architecture, and here I mean technologies like maybe superconducting with photonic to deliver a value. So that's yeah, it's still possible. I mean, we don't know at the moment, but maybe in 2 or 3 years this will be revealed.
Okay, thank you, Dr. Taha.
There is a question here from Greg as well in the chat.
Yes. Okay, the question is, why does IBM keep changing Qiskit and not making it backwards compatible? This question from, yes, from Greg.
Ahmed, you want to start?
Okay. First of all, thank you, Greg. It's a very good question, and I heard many times from many different people. And there are many reasons, and I think it's very logical and obvious reasons. First thing, Qiskit is an open source tool, so everybody's contributing to evolve this SDK. Second thing, if you look into the roadmap for IBM, you will find out that the hardware itself is keep evolving. The way that we are designed, the chips, the quantum chips, the qubits, the connectivities. For example, the latest connectivity on the Nighthawk chip, it's a C couplers connectivity, and we have the heavy hex connectivity for the qubits on the chip. So these changes on the hardware enforcing us to change the way that the SDK is dealing with this hardware. Okay, so the SDK or the function.
If that's the case, then why couldn't that be taken care of at the compilation level?
I think this will come, but IBM will not do everything. IBM is doing the foundations, is doing, let's say, the hard part, and let the business partners and the startups start improving and keep developing things. Yani, for example, IBM announced the Qiskit functions. It's a program for the startups to build their own algorithms, maybe circuits, and we have, by the way, two types of functions, circuit function and application function. If we look into the lower level, which is the circuit functions, some business partners like Kidma, for example, and this is one of the business partners that proposed their solution, their function on the summit. They use their own protocol for the for the error suppression and the error mitigation. So they deployed on IBM Qiskit function, and anyone wants to use this function, he can involve it inside as part of his circuit. So we are relying on the community to fill the gaps. As I told you, IBM is working on the foundation, let's say. Whatever we can could be complemented by the ecosystem, we are open for that. And that's why IBM, if you look into even the levels of the innovation roadmap, which IBM is doing experiments in the lab, the connectivities, definitely I'll go back to the low level architecture, because at the end, we're still in the early stage to develop your own algorithm, right? You need to take care of some hardware architecture to be able to design the proper circuit, okay? IBM is still working on these abstract and intermediate layers, trying slowly to decouple the algorithm and building or encoding your problem as a circuit, and make it more independent than the hardware. And this is what we are trying to hit by having the abstract layer of functions. And if you look into the dynamic circuit and how the Qiskit itself, the Qiskit full stack, it has this middleware layer where we have the transpiler where it will optimize your algorithm based on the underlying hardware. It's an intelligent way to get your circuit, try to optimize it on the chip that you will run this circuit against. So I hope.
I appreciate what you're saying there. It's just that for us to have to rewrite Qiskit from pre 1.0 all the way to present, that's thousands, probably hundreds of thousands of man hours to redo that. And it's just not possible to do it. And I know of quite a few programmers that now refuse to use Qiskit because they don't know what's going to happen next week or next month when the next version of Qiskit comes out, and they've got to rewrite it, and they can't keep developing the new code that they need to do as well. And so it's more of a business question than a technical question, but also that there was another point I had, but in any case, more of a business question, because they're violating one of the primary rules that's always been in programming, is you always try to make it backwardsly compatible for this very reason. It's impossible time-wise to make all that up again.
It's a valid concern, but definitely the era, if you look into the quantum era that we are living, we are still building the system from scratch. And I think this is like a fair price that everybody should pay in these early stages, because we are all still discovering this new world. Still, we are building the foundation. I do understand what you are saying. I totally agree that from business perspective, it's a costly, it's not an easy task. However, yeah, I definitely, it's all about money. I know. However, we are clear when it comes into the roadmap and what we can achieve and what we cannot achieve, and what we are trying to work to build, like a reusable and portable quantum systems that, let's say, we need to have it like a general purpose quantum machine, which is, we still far away from achieving this. We are designing, as you know, designing the algorithm based on the machine or the processor that you're working on, based on the functions available, the abstract layer that IBM is giving to you. But still, there is a lot of room for innovation, and that's why we are relying on the community to complement this. If you look to the basics, IBM has two missions in quantum. Make it quantum useful. It's not only IBM, it's IBM plus the community, and make a quantum safe.
If I can add a little thing here. So IBM does, as Ahmed said, does a like amazing and also extraordinary work to move forward. And also Qiskit now is tightly integrated with the hardware. So previously, Qiskit was intended to be a generic software development kit for quantum computations, but more and more with time, IBM is also making it also tightly integrated or adjusting it to adapt with their own hardware line of production. So this is why there is are major updates that happen from here and there. And of course, as Ahmed said, IBM relying on community. What we do in certain cases, like this. So we have also some problems similar to this, especially, for example, in chemistry simulations or in physics simulations. So what we do, we develop our own part of the simulation independent of Qiskit. The critical part that would require significant hours and update. So if we can afford it, it will be great. If not, we make an independent code to write it, and then we connect it to Qiskit. So Qiskit also provides APIs to do that. And with these APIs, once you establish your Hamiltonian of the problem, you do all the pre-processing, the pre-preparation of the things. Then you integrate or you provide the data as an input to the API of Qiskit, and then you can leverage the Qiskit runtime, the Qiskit sampler, all kind of simulators that are there, noiseless and noisy simulators. You can benefit from IBM if you do your code. And this is what we do now. We have, for example, Julia-based package. We develop everything, and then we subcontract to Qiskit at some point to leverage their intelligent transpiler and also to run some computations on IBM quantum hardware. So there's also a question in the chat from Dr. Ahmed.
Thank you, Dr. Taha. Thank you, Greg. I think this is the last question in this section. Dr. Ahmed Musa asked about the alternative. Do we have? Is there a competitive alternative for Qiskit?
Yeah,
So,
maybe I
yeah.
can start the ball rolling to
Yeah.
wave So Ahmed is an active IBM voice here indeed in the session.
Okay, yeah, definitely. We are not the only player in the quantum. We have a lot of vendors, and all they are trying to deliver the best for the community and to the world. There are many, like what we call it, like libraries, SDKs in the market, like Circ from Google, Q Sharp, Microsoft, Penny Bracket, and all these SDKs. The short answer for your question, there are alternatives in the market. However, there is always a trade-off. And in a previous session where I gave like a comparison between the performance of Qiskit compared to the other SDKs exist in the market, and there is a huge difference when it comes into the speed, the efficiency, of the Qiskit, running Qiskit versus the other SDKs that you have in the market. Yes, definitely there are many SDKs in the market that can run, but let me tell you that around 70% of the worldwide developer, they are using Qiskit to build their own quantum algorithm.
And also, Qiskit is quite fast, is also quite optimized for certain tasks. The only problem is that, of course, still the community is growing the library reserve about Qiskit. But now companies have their own also packages and the frameworks as well. Like, for example, in Molkit, we made a partnership with Quandela, and Quandela is using Percival. So because they are photonic chips, they are using their own simulator. But other companies, as Ahmed said, they are using also relying on Qiskit to run on a quantum computer. So you can do, for example, the classical code, everything in a like the way that that we like for example in Julia or in C++ or anything, and then we interface with Qiskit to perform the computations. Alternative packages provide some value, but it depends on what we are looking for. So Google has Fermion and had also Open Fermion package. MATLAB has a simulator, but of course it's not noisy, so MATLAB does not provide, as far as I know, I mean, also I could update this part, the hardware simulator. So IBM has this because they have the noise. They try to emulate their hardware in the simulator. Similarly, other hardware companies, but typically software companies, they have a very good SDK. In Molkit, we have SDK ourselves. We have our own simulator, but it is noiseless because we don't have a hardware. I mean, we can introduce a fictitious noise based on the type of hardware that we would like to imagine, but this is mainly coming from the theory. So to alter the rotational gates by certain factor, add some randomization in the measurement and so on. And then in that sense, we are emulating what happens in the actual backend. So that's what research groups and schools, universities, everyone around the world is trying to do, is to create their own local package. But at some point, they have to interface either with Qiskit or with other for the platform in order to perform the computation on actual quantum computer, or to use or to benefit from a noisy emulated simulator from a hardware provider, either Photonic or IBM or Google or anything. Yeah, so there is continuation of the point from Dr. Ahmed. There is also some people who are drifting from Qiskit, but of course it depends on the use cases. Well, maybe Ahmed can start the ball rolling in this question, and then I will make my comment.
Yeah, I mean, thank you, Dr. Ahmed, for your comment. Really, it's to the point, but let me emphasize on one thing. Yeah, IBM is not leaving the Qiskit totally to the community. IBM is developing as well, co-create the functionalities of Qiskit, and plus the community as well. So we are not totally leaving the Qiskit to evolve with the community, because we are building the foundation that support our hardware. The portability of the Qiskit, yes, we know that it has some limitations like the backward compatibility, but this is the price that we should pay due to the evolution when it comes into the underlying hardware. We are trying to build more powerful quantum systems, and definitely this keep changing the upper layers on top of the hardware. I don't deny this. I do agree with you. However, this is what IBM is trying to do the balance. We are helping the community to develop and evolve around Qiskit, supporting our superconducting type of chips that we are developing.
And yeah, a small comment from my side. So the IBM is also relying on the community that they can make money out of Qiskit and Qiskit catalog, so and the Qiskit functions. So by doing so, then more and more people will get committed because they will benefit from the marketplace of Qiskit. That where marketplace will have many functions. Now there is functions for partial differential equations, function to solve a linear system of linear equations. Functions even to do some certain things in chemistry and so on. And then that marketplace will turn out to be something like MATLAB. So there's a lot of toolboxes to download and import. And from these toolboxes, then you can do computation instead of programming them. However, if that could be beneficial for the average developer, but if someone wanted to develop something unique or out of the box or not in the conventional Qiskit package, then they do it differently, separately, and then they link it or outsource Qiskit whenever the point comes in.
Okay, thank you, Dr. Taha. Thank you, Inja Ahmed Salim. Now I'm moving to my colleague Omar. I think he have a question for you.
Before I start, I see Greg has a raised hand. Do you have any questions, Greg?
Thanks, Amar. Yeah, I did. I just wanted to generalize what Ahmed and Taha said is I fully agree with what Ahmed's saying is that the hardware is changing so quickly for everyone. But the other thing too is what we program, let's say, on an IBM system isn't going to run then on an Atom system or an Ion system. And so we have to put completely different code in all these. We haven't progressed anywhere near to the level of what is done in classical computing yet, let alone try to keep it on just a single. And so there's a radical amount of change that's going to go on. And many of us strongly feel due to the speed problems that Python's not going to be the language. We need a compiled language, not a just-in-time compilation like Python does. It's entirely too slow, and it will not be proper to use once we start to get to thousands, let alone hundreds of thousands of qubits. So just to overview is that anything, even if we could come up with one in this group right now, is that it's not going to be good in another couple of months, let alone 2029 on anyone's technology. And so I was just saying that backwards compatibility to hopefully help a little bit. And yes, as Dr. Musa also said, is that the business aspects as well. But no, I'm aware of that. So thank you both for adding to it.
Right. So this actually was a very great and wide field that we can discuss more and more and never get done with it. So just we want to go back to our main frame, which is reference on the IBM Quantum Summit. So I just have a question. Like in the past few years, we heard a lot about the quantum utility, like the idea of how quantum start to make a real value or give a real value before we reach out to full tolerant machines. And I think in the summit in Amsterdam, like it was obvious that this was something IBM focused on. So let me ask you, have we seen a real steps towards the quantum utility, or is it still coming?
Yeah, everybody's talking about the quantum utility, quantum advantage. So let's define what is quantum utility so we can have like the same understanding. So quantum utility, it means that you have a problem. It could be solved by a classical machine and the quantum, but it's better to be, if we use the quantum machine, it will give us a better value. Maybe this value, it might accuracy, might a shorter time, lower resources, whatever, the better, what you define better is, okay? So this is the quantum utility. And to answer your question, one of the use cases that IBM succeeded to use these noisy systems, quantum system that we are using as of now, a use case and the partnership with the HSBC Bank in UK and the trade portfolio to predict the bond trade portfolios. the market improvement like around 30-35% better than the classical computer. But let's be open, let's be transparent in this case. Yes, we achieved with the quantum system, with a noisy system, improvement like 37% than the classical. But the most important question is, if we have the time, the money, the resources, trying to run this in the classical, we can achieve it, by the way, the 35%, but after maybe 2-3 years, right? With how many resources, skilled resources that we need to work and how much it will cost, okay? But this will give you a glimpse about how the quantum is evolving. Despite that we have a noisy system, still we can achieve some useful, run some use cases, and we can succeed to do a remarkable change in different industries, by the way, okay, not only the financial, but we have many use cases in different industries that we achieve a remarkable progress when it comes into using these noisy systems. And this is the way that IBM is trying to reach out to the customers, because at the end it's not a matter of, okay, let's get a use case and jump into defining the algorithm and write it. It's a very complicated, very lengthy process, because first thing, we need to understand the business, analyze the problem, what are the expectations, plan to the success criteria, how many resources it will be consumed in this journey. So it's not like an overnight activity that we will pick randomly one use case and start working on it. No, it's not that easy, because we know, and the client know, that we are doing a research and experiment in a noisy system, right? And this is clear from day one. And once you achieve these 37% with what you have currently, I can see that the future is more promising. Okay, so I will not take much time, and then some Dr. Taha to comment.
Yes, I'll add some more follow-up question, but over to you, Dr. Ta first.
Yeah, so yeah, that's I think that's a very nice answer indeed. I mean, it's all the time is things are about the development, and also that, as Ahmed said, that in 2 or 3 years, what will happen? That's what we are gonna wait for. So to summarize one thing, the difference between the advantage and the utility is that advantage is mainly also caring about the computing efficiency. So what you wanted to do as a quantum computer, that's also efficient. So the utility is a proof of concept that you can do something that natively on quantum, and then the quantum can deliver a value. But then when you come to the advantage, you have to get something out beyond what you can get with the classical, either speed or accuracy, or even sometimes, as some advocates say, energy efficiency.
Yeah, that's
Uh,
very great. Yeah.
I
So,
have a question. Can I ask a question?
sure, Dr. Rahi, go ahead. Yeah.
Thank you. Good evening for you all. I have a question to Engineer Ahmed from IBM. Engineer Ahmed, what about the fault-tolerant quantum computer? Your roadmap said that it will be available in 2030. I have a question if it is still running or not, or if you have any modification for this date.
Okay, thank you, Dr. Wahid, for your question. As long as it's announced, we are committed to it. This is the short answer.
That means we have to wait 4 or 5 years. Okay.
No, not like it's not like a black and white and overnight at reaching the fault tolerant quantum computer, because we have a long way to achieve that. A lot of hard work we should do to be able to reach this stage. But it's not don't take it like we need to wait till we reach the fault tolerance and start getting benefits out of the quantum computer, as I just mentioned. This is one of the proof that we can, as we speak, using a noisy system, get advantage from the quantum machines, and they can solve and add value to our business.
But the problem is with noisy system, we have very يعني we have limited application for quantum. As Dr. Taslim, I think the most application used with quantum now is simulation, for especially for chemical application. But for other application, engineering applications, for example, material, other applications, we need fault tolerant system.
What I can say, if you look into or log into IBM website, you will find a lot of engagements with many big companies worldwide, working hand in hand with IBM in many different use cases. Like Boeing, we have many use cases that we are working with them to discover new materials, sustainable materials for the airplanes, for example. We are
Using quantum technology.
using quantum, yes, absolutely.
Yes.
We are working with Mercedes. We are working with CERN, ExxonMobil for supply chain and optimization. We are working with Motorola. We are working with the Vodafone for network optimization. We have a lot of use cases across different industries. Okay.
Okay.
So whatever we achieve a progress or a remarkable solution that we can announce, we are doing it right away. But as you know, and this is clear for even for the client, we are working hand in hand with the client. Everything is clear. We are still in the research phase, and definitely these clients, they are believing in this technology, and if they don't see that there is an ROI behind this, they will never do this.
Okay, that is clear. Other question is, what about IBM and artificial intelligence? You are focusing on quantum. Are you have any development to integrate the artificial intelligence in quantum?
AI, it will work both ways. AI will support the quantum computing, and quantum computing will support AI.
There is a very mutual coupling, yes.
Exactly. IBM has, for example, the Qiskit code assistant. So you can just describe what you want from this circuit, and the code assistant will build for you the code. Okay. So
Yes.
this is one of the use cases that we are using AI to serve the quantum. But what is the other way around? We need the quantum to serve the AI. How we can do quantum machine learning using
Quantum machine learning, yes.
quantum machine. But till the moment, as Dr. Taha mentioned, IBM is relying in a heterogeneous environment of quantum machine. It's not only a single quantum machine can do that. It's a quantum machine with GPU cluster and CPU cluster. So it's a matter of combination between all these, because each and every technology is doing part of these
contribution, yes.
Exactly.
Okay, yes.
And this is what IBM is doing now. We are having partnership with Foco in the Japan. They're having the largest or the most high performance computer. So we are doing the most of the workload that the HPC can do, okay, and make it hybrid with the quantum machines. So, and we are keep evolving. And let me refer for one of the discovery that Dr. Muhammad Zidan has mentioned is the QRAM, the quantum RAM, which is
quantum RAM, yes. Dr. Muhammad Zidan, yes.
Yeah, I think this is one of the key stages that we need to achieve or run a quantum machine learning in a quantum machine, let's say. And IBM announced Loon as the foundation for quantum memory.
I contacted him. He has a dream to get one day with general purpose quantum computer, as you said, but it is still we are still far from general purpose quantum computer with compiler, with software layers, etc.
يعني look, the same of the classical, the way that we start the classical
We
computer.
start, by the way, we start, yes.
Exactly. But as long as we have bright mind like yourself and all the professors worldwide, definitely will achieve something and will reach for what the humanity is aiming for. This is my personal belief, because I do believe as long as we start something, definitely so we know about it, and every day you are getting experience, getting knowledge, and keep evolving. And by the way, we might reach to some points that we didn't even imagine that we can reach for it one day.
Thank you, Dr.
Thank
Ahmed.
you. Thank you
Remember
for
the 4 MB memory that is the size of a room, okay? You have
okay.
now a small USB with 1 TB.
Yes, you're right.
Thank you, Dr. Ahmed. Thank you, and Dr. Wahid, for this
Thank you.
follow-up and adding to my question. I just ask if anyone has a question, just type it in the chat, and you can follow up after that in order to make things smooth and so on. So I was asking about quantum utility, and Dr. Wahid he added a very important value to that question. Like when do we reach to the full tolerant quantum computing? And let me rephrase this question. So, from your own point of view, what is the factors that tells us that we have reached or that we are close to the quantum utility? Is it like in the hardware or error mitigation or some use cases? What do you think about that?
Dr. Taha, يعني you didn't talk in the other day in the last one, so
Uh,
you can
Yeah,
start.
so complicated question indeed, but yeah, thanks, thanks Omar for it. So yeah, so it depends now on let's back back a bit about and go back to the definition of computing. What we need from a computer to do, and then Alan Turing in his thesis already defined the way that you do computation. And the Turing machine is like a machine which you can achieve a certain computation. You have an input or some inputs, you mix them in a specific sequence or you perform some sequence of operations on them, and you achieve another point in the computation using this machine. So that's what's expected. So now if we look at the quantum computer, theoretically, it can do everything that the classical does. However, we come from physics world, so we have the theoretical way view of a quantum computer, and we have the practical way of looking at it, or the physics perspective. And the physics perspective will be, okay, how much you can contaminate from a qubit, the number of qubits you can squeeze together in order to form one chip, and then the communications that you can do between the qubits, the energy that you need to in order to keep the system running, and the coherence time, the lifetime of the qubit, and also the coupling between them, the interactions, and also the isolation from the errors that might emerge from the coupling or the interactions with the environment. So now, to achieve a computation in the future, or to say we have a quantum advantage, this is now the purpose. Now the quantum utility, we should have surpassed it now. So I mean, it has been proven there is a lot of competition all around with a quantum computer, but the main quest now is to seek the quantum advantage, to prove that you can do the quantum utility, but on the top of that, you can use the resources optimally, and you get efficient resources while you are maintaining good speed. You can get accuracy more than what the classical computer can provide. So that's the quest. So to achieve this, you have a physical system which in theory should be equivalent to what you do with a pen and the paper from a computing or the Alan Turing's perspective. And then with these two equivalent schemes, how you can achieve a computation that you do in classical. So in quantum, you have these errors, the coupling, the coherence problems. the noise. So to achieve this, you need like breakthroughs in all of these dimensions: error corrections, the fabrication of the chips, the noise, suppressing the noise that might come from the environment. Even some people are now proposing to send a quantum computer to space, so it's more away from the gravitational effect and the heat, the thermal heat on Earth. And plus that, you need a very good benchmarking and a very good software to use it. And that's a perspective about this to get an advantage. So you can develop a good hardware, but if you don't have enough use cases or you don't have enough algorithms to run on it, then you still have a good tool, but you don't know how to use it. And this is unfortunately might be the case with some of native hardware which are good, but still there is the algorithms should be developed more to work with the native architecture of the hardware. So not to map a certain algorithm on the hardware and then you end up with a very lengthy circuits with many gates because of the theoretical approximations. Like you need a unitary operation to act on a qubits, and then this unitary you can say, okay, if I decompose it theoretically, I will end up having this many swaps, this many C nodes, this many Hadamard, this many X nodes or Pauli gates, and so on. So you might end up with very long circuit. However, if you adapt your algorithm or you develop an algorithm natively for this particular hardware, that also an advantage. You might end up with a very short circuit and then get a benefit out of it. So you see, like there is algorithmic development, the breakthroughs that might happen in the error correction, which are now very prominent from IBM, like Gross Code, but also from Google and other players as well. And then you have the physics, you have the RAM, which Ahmed mentioned already. There is extensive need for the RAM, how you can preserve the information, the quantum state, and put it aside before, so you can use it later at a later stage. And this also will need optimization because also the RAM will be quantum RAM, so you still have the same issues as normal qubits. And the development of the fabrication techniques as well. So we have Dr. Ahmed Shawqi Musa here, also from the computing. Maybe we can direct the question from him what he expects from the quantum computer as an HPC expert to see.
Yes, indeed, this will be a very good question because, like, actually, some companies might be a little bit schematic. If quantum is not ready, why should I join? This would be a very follow-up question if you eager to answer, Dr. Ahmed.
Well, I'm not eager, but that's a difficult question. So I'm not eager, but I will try to answer. First of all, I'm not really good at expectations, and I don't like to guess and expect. I like to calculate and move towards something rather than guessing something. But if I have to make my best guess, I think it will be the integration of hybrid systems, which as Engineer Ahmed talked about, and during the hackathon, I also mentioned that in my talk, the effort being done between IBM and RIKEN in Japan, trying to define on the instruction level a way of the integration between HPC systems and the quantum systems. And I think that will be like a turning point in the history of quantum computing. I'm not expecting, I could be wrong, but I'm really not expecting that the quantum computer is going to replace the classical computer, or that the classical computer is going to eliminate the efforts of building a comprehensive quantum computer. I think they will both progress, but my best guess is that the future is for the integration of both. And this is why I'm not really a good programmer in quantum computing. I only tried it out of curiosity and interest. But my interest in quantum computer is coming from the architectural point of view, because in classical and HPC, I'm an architect myself. So I started thinking about the architecture and not architecting the quantum computer as a physicist, but as still an HPC, as a high performance computing person. And this comes from the integration. So I think there will be a model of integration and combining hybrid systems to work together. Regarding the memory issue, I know this is very difficult. I think a physicist should answer this much better than I do. But again, as an architect, I'm thinking of a way of preserving the state in a different hybrid mode. Like, for example, if we are able to integrate the HPC and the quantum computing at a certain point, if we can create entanglement that can be transferred to the HPC system to preserve the state and keep the computation going with the original bit or bits on the quantum computer, then in this case, we might in the future have reversible quantum computing and memorizable quantum computing system. Well, I hope I answered as much as I could, but it was a trap. It's a very difficult question. I was not eager to answer it. But thank you anyway.
It's very different. Yeah, really. So thank you, Dr. Ahmed, for this adding up. Thank you very much. So back to you, Engineer Ahmed Slim. What do you think about that?
I can't agree more about what Dr. Ahmed Shawki just mentioned. The future is the hybrid approach where you have quantum, classical HPC, and even the AI infrastructure working together to add value. No way quantum will replace any one of these components as we speak. We don't know what will happen in the future, but what we can see from the architecture and all the
We lost voice. I'm not sure if this is on
Yeah,
my
I
side.
lost it.
Okay.
I lost it too, but I thought it's a problem in the internet. Ahmed, we don't hear you.
Hello, can you hear
No.
me now?
Yes, we can. Yeah, go ahead, please.
Sorry. I don't know from where you you lost me, but let me repeat what I just mentioned. We do believe that quantum computing will not go or break through alone. Definitely, the hybrid approach is the way that we can take the quantum to the next level. Quantum machine with classical HPC plus AI infrastructure all together will collaborate to deliver a value. As we speak now, IBM released the Slurm. This is like a job scheduler to start I think Dr. Ahmed Shawki knows about it, to start managing the jobs and running the job in the classical HPC, and IBM released it in the market as an open source. And having this direction, I can tell that this will be the future, or this is the approach that IBM is taking. It's not only the quantum, definitely it will be quantum plus the classical HPC.
Thank you very much for that. So the question I was asking this question because as I said, some companies might be worried about the future of quantum, and this may affect also policymakers across different continents. So, for example, if we come to Africa, how do we convince the African leaders or the stakeholders to put more effort or to put some ecosystem in quantum. So I believe that IBM influence some wider ecosystem in the next one or coming 2 years. So how do we do that?
Oh, yeah, can I start the ball rolling in this question?
Sure. Yeah.
First, as also Engineer Ahmed said and Dr. Ahmed, that's also a perfect answer. And also the comments that Greg and also Dr. Wahid has already made. We need like breakthroughs and many things in quantum, like the RAMs, hardware, and for example, the work of RAM, like what Ahmed mentioned, the QRAM of Dr. Zidane, but also the other innovations in the field. So you need to achieve all of that. And because that takes a lot so time, this achievement in error corrections, the RAM, the fabrication, the physics itself, development of the engineering techniques, understanding of the hardware, that takes time. So the majority of the community don't see any useful or a quantum advantage that will come in the near future. So they might get that impression. However, major players, they see the future. Like you have seen the OpenAI, they forecast that the AI will boom in 10 years. It started from late 2000, around 2007, 2008, starting to work on that. And we are talking about an average 10 years of development to achieve what we see now as ChatGPT 3 and 4, and now we have 5.1. So that took some big chunk of time to arrive there. So there is no direct translational advantage of quantum. It needs education to see it. So the only way to bring the leaders is to educate them about what the quantum computing can do for the society and for the industry, and also for applications in general. It's not only about the great pressure that people do on LinkedIn. Oh yeah, your computer will be hacked with quantum, or you will get your data will get lost. There is many applications that's very tangible to humanity, like the drug design, the understanding of diseases, the evolution of certain molecular degradation in the brain, like for example dementia, and many things you can understand in a different way if you do it on a quantum computer, because the way that the algorithms are designed. So there is more physics and science you can get. So you can educate people about these benefits. So the innovation level that can come in chemistry, material science, drug design, medicine. The second thing, in the sensing itself, that the knowledge could be used to develop much better sensors. So it can be reflected to the industry. You can obtain certain industries like detecting rare earth metals under the ground, oil, other metals like gold or silver or even cobalt, some materials that are very vital for the industry. The third thing is the communication, that you can ease communication or encrypt your data, so you can keep the end-to-end encryption or protect the privacy with it. So all of these use cases could be like delivered or presented to leaders so they can understand the potential of these applications. On the top of that, also the community, what the community does to provide this, like so working in quantum, providing education, working in research, doing all of that help the quantum industry. But not only that, but also the all of the skill set around the quantum helps also to bring better workforce. There is a report from McKinsey was published a year ago or so, that now the workforce has is increased in skill set by about from 10 to 15% on average, due to the all quantum activities around the world. It's not only related to quantum computing or the quantum industry, but this is also has been reflected and echoed in the semiconductor industry, in the battery industry, the car industry, the AI itself, because of all of this collective knowledge and the skills help it in that. So teachings and what can be done from a research and innovation perspective, what will be is a reflection on the industry, what will be the benefit or the added value for the workforce to attract foreign investments and the companies, because companies want the best workers to work at their factories and their offices. all of that can convince the leader, yeah, there is potential in quantum, but you need to see it in that way, because it's also a complicated topic. So it needs some time. So starting by events like hackathons or conferences where people can meet and discuss potential applications could be a good way to start or to get the ball rolling for emphasizing the quantum ecosystem in the region. Not only the region, but worldwide, like United States, Europe also as well, and Australia, Latin America and Africa, but also in Asia. All of them, they start with aggregating certain activities together, doing a lot of activities, and also IBM did very great job in that by like stimulating a lot of summer schools, hackathons around the world, and that also benefited a lot the workforce.
Yeah, thank you for that. I'll back with some follow-up question, but let's go first to Inja Ahmed. So what do you think about that?
Actually, the community and the ecosystem, one of the main pillars to support the quantum and spreading the awareness and all over the world. And as you can see, IBM is trying to support heavily and invest even on this. Fall Fest, for example, IBM is sponsoring many Fall Fests worldwide, and it's open for students, universities across the globe. Even the it's all about, in my point of view, it's all about vision. People, they invest in vision. I will take the same example of just Dr. Taha mentioned in OpenAI. They are putting billions and billions of dollars, and despite that they are they are losing, they are getting more money. How they are getting these money? Because people, they are investing the vision. And if you would believe in this technology, definitely we'll start working on it. Maybe we need like some enablement, spread the awareness through hackathon, like Dr. Taha mentioned, meetups, maybe many regular meetups, some online enablement, like what Dr. Taha is doing in the monthly series, the AI lab weekly. So all these activities is building the hype, make people more excited, see what is going on in this new technology, and definitely this will make some awareness, some excitement that we have something new. It's worth to look into it, invest into it, and even take it to the next level with what we have. And if you look into all quantum strategies that has been announced worldwide from UK, France, Canada, Australia, Japan, you will find the ecosystem at the heart of this strategy, because without the ecosystem, without the community, will not be able to discover where are the potential use cases, who will the workforces, where you can find these workforces and all this stuff. We have many resources, but we need to know where are these resources and get the maximum use out of it.
And regarding the quantum strategies, which is a very good point that Engineer Ahmed has mentioned, we also started to the ball rolling in the quantum strategy, for example, in Egypt during the hackathon in Alexandria. So where the Dr. Ahmed Shawqi Musa was present, and also Engineer Ahmed Salim, and we had many other collaborators that were there. Potentially, maybe Mr. Greg wanted to be part of this in the future, but we had a very nice community that has been there in the hackathon from Europe, from the States, from Australia, and also from the Gulf countries and different countries in Africa and the Arab world as well. And all of this blend between the industry and the academia formed a basis for what could be a good group to define a quantum strategy. Like you need people from education, from universities, and from industry as well, and also from community development. And all of that can shape the strategy, which Ahmed has mentioned about the central core part of any country or a region to start activity, to start like making all of these illumination of knowledge about the quantum, and also what you need to achieve in the near future, which part you need to focus on, and so on. And there is also some efforts that are done to initialize this, and also to stimulate the way that we to stimulate the collective thinking in quantum strategy, and also the quantum work. Like for example, there is potential activities that will start with Dr. Ahmed Shawqi Musa soon, about quantum AI and the integration between AI and the quantum. And that's very nice to stimulate this, especially in a new ecosystem like in Egypt, where there's a lot of workforce, but they are eager to learn about this knowledge. So that's a very good example, and can kick start very nice future series of activities next to what we are already doing in hackathons and in quantum AI labs, and all of these individual activities that combine people. When we are all talking science, we are trying to explore the unknown. So that's always a very beautiful thing, and will help advancing the technology more.
Yeah, that's actually very great, and I couldn't agree more with what you're saying, because at some point we're going to need quantum, like classical computation wouldn't hold anymore. So yeah, I have one more follow-up question. So what does actually take for some startup to begin initiate the quantum ball rolling in Africa? What are the requirements? What are the step-up areas, the field, or something? Maybe over to you, Dr. Taha, then Inji Ahmed Salim.
So indeed, we with Engineer Ahmed Salim we are also exploring startups at the moment. So I can talk about from my experience in Molkit. So first, you need a very clear strategy, where also there is academia in between industry and universities who oversee these things. We have also Dr. Ahmed Shawqi Musa is also an expert, and also industry expert and academic expert in HPC. So it's a good example of this. And with this vision, you can support the students at the later study years, like for example at the last year of the bachelor program or in the master, to spin off from the university, like to how to convert the research or their project, graduation project, or the master thesis, or even the PhD work into a company. So that's the first thing, how to convert this work into something that could be marketable in the near future. The second thing is the investment that universities, because of this vision, need to understand that this is somehow will give them very nice feedback loop. Because if the company started to spin off, the founders, which are fresh graduates, either from the bachelor or the master or the PhD, will find their job. So they will not struggle to find a job, because the job is there already. The company already has spun off. And part of the revenue that will be returned to this company will back to the university. So the university will benefit from this money in labs, in providing equipments, enhancing the facilities, and so on. So now this is a good thing. The main element next to these two is the customer, is that also the vision should include very good teaching about the market. Now I wanted to make a startup. For what good I wanted to do. So if someone said, okay, I want to make a startup to write an algorithm for string theory, who's gonna buy it? Who's now interested to buy an very expensive algorithm to write an equation in 11 dimensions or in extra dimensions to understand the universe using string theory? I mean, it's still complicated if you think about it. It's not marketable at all, and maybe one in the whole world, one research group will be interested or two. So the culture of thinking about the applied research towards the community or the industry, that should be emphasized. So and if this is emphasized, then the customer will be guaranteed. Like if, okay, we are doing something in physics or in math or anything, what we wanted to achieve with that. Is it research, or it's more a project that could be marketable? So that's also the role of the supervisor to decide about this. So some in the Netherlands, for example, there is main extreme focus on this. Everyone, mostly when they finish their degree, there is incubators in every university to think about, okay, now you are finishing your research project. Can you think of applications that could be marketable of this research? Some people do genetic modifications of flowers, so they can use this knowledge or recycle it and, for example, enhancing certain crops. Some already developed new proteins that could be part of drug design. Some like us, for example, we're doing algorithms to enable some chemistry simulations. So there's a lot of things need to be emphasized. But all of this, we are seeing now an ecosystem for that. All of this starts with the university. You need teachers who can emphasize this in workshops and educational programs in order to make the students or the future graduates understand the necessity of this for the market. Because if you don't do this, okay, I'm focusing on research for 20 years, but then I don't have funding. There is no job. There is nothing. So that's also a way of optimizing the workforce. Okay, who can do this and where and when and what according to the available resources. So to summarize, we have 3 main points here. We need incubators, and we also, Engineer Ahmed and I, with other collaborators, who were thinking of like a business park, which can also help startups. You need also good professors who have a good vision between the industry and the academia to give and promote presentations, and also lead strategies for this to emphasize this. So like there is tendencies that academians or certain academic professors, they focus solely on the research, what I wanted to publish next week. But then these publications might not be tangible for the industry, so they are not fundable by companies. So that needs some education. Which part could be considered as a fundamental research and which part could be considered as an application? The third thing is a student. We need to teach a student, okay, now, do you do something applicable? Is it marketable? Do you want to consider to start a startup? And maybe the whole team of the graduation project can do this with the help of the supervisor of the project, plus some business developers from the university, and make the universities understand that this is a win-win situation. When this company spins off, when there is a customer and this company makes money, the university will benefit indirectly from the revenue as a shareholder in this company. So that will be translated into main benefits for the facilities of the university.
Yeah, thank you very much for that. So over to you, Inja Ahmed, and I made at some other point. So in the summit, have you seen like if there's any a gap between the infrastructure between the companies was there and in Africa? So you might answer that as well.
Okay, for the startup, I think it's a golden opportunity to anyone who has an idea in quantum and he can spin a startup and start working on it. Definitely, it's not this easy, but still it's a new science, a new technology that it's keep evolving. Every day you can see publications worldwide around the quantum and the use cases, different use cases. So the good starting point, I think, like what Dr. Taha mentioned, is starting with the researchers, PhDs and masters, and all these projects that still on the shelf. Okay, you need to start with it and start monetizing it. Okay, so you need to find a high value problem. And this high value problem, you need to have an expertise that they know the technology inside out. Definitely, you need an industry expert just to map the problem to the quantum world, so you can have this linkage. Then you you need to have to select a quantum provider, a trusted quantum provider that you can build your MVP. Uh, IBM is definitely have a startup program that it's open for anyone who has an idea, has a research. He can just document it on the website, propose this idea to IBM. They will study it, and if it is valuable, it has a value, it's compatible with IBM platform, they will start monetize it. Okay, so I think this is one of the easiest way that you can penetrate the market and have a startup, a running startup. Definitely, it's not easy because there are many criterias to have your function deployed on an IBM function catalog. But this is one of the examples that anyone from maybe the PhD students or master students can start with, and they have his own startup. Um, Many investors now start communicating with the universities here in the Gulf area to turn these researches and theses into a valuable product. Okay, and this is start as we speak. I think this is the right way and the fastest way to have a win-win situation. The university, like Dr. Taha mentioned, they will get benefits out of the startup that it will later on commercialize its product. And the startup will work on a problem that will serve the business, and it will solve a business case, that a real business case, and deploy it, and everyone will get benefits out of it. Or maybe you can find someone else to build and improve what you just built. Okay, so I can see it's like a circle. It has many key players and many stakeholders in this. The awareness is very important. The awareness will come from the ecosystem as well, but there are many players to be able to have a proper startup. The chances, as I can see, it's a very good chance as we speak. We are building the industry, not we as a small group, but we as industry players. Okay, we are building a new industry, and the door is open. And it's a very golden chance for every and each one who has an idea in this field to make it bright and to do the proper partnership, find the proper investor, and this definitely will take the whole industry to the next level.
Mm.
Yeah,
Mm.
thank you very much. Yeah, yes, Furgani, go ahead, see you.
Actually, I want to take advantage of this question and ask Professor Wahid and Professor Ahmed Shawi if we could try this model in Egypt.
Yes, yes, I try to establish a research group in Ain Shams University with my colleague, and we try to attach some students, master students, to work on this in this area. I think a research group maybe a research group to start like Dr. Ahmed Yunus in Alex. I think we try to do the same thing. Okay, and I hope in the near future it will be grows up.
Okay. Thank you, Dr. Wahid. That's
Thank you.
promising. Yeah.
Uh, Well, on my side, I might sound a little bit more pessimistic because establishing a research group is not difficult, but the objective and the motivation behind the research group is going to be mere scientific interest. But here the question originally started about startups and building an ecosystem. This is different. For the students to consider quantum computing serious professional study, they need first to see the quantum computing in their future, either in terms of jobs or startups. startups, well, I appreciate very much what engineer Ahmed Salim make it look like a bit easier, but it's still not easy because they are going to invest and work on doing something with no customers, like Dr. Taha mentioned. So I think a way of overcoming that is maybe for a program to be created at IBM, not to wait for new ideas, but maybe to pass the simple ones to startups, to be in a way outsourced to small startups to work on. And in this case, they get the ball rolling. But for graduate students to fresh graduates to form a startup and work on something that might be marketable in years from now, even if we say 2 years, who is going to wait for 2? How are we going to feed them during these 2 years? They still need to live. So last point is about the incubation of the universities. Frankly, I don't see this happening in the near future in Egypt. Right now, the Egyptian universities are not in good shape in terms of financial support, either from the state to the university or from the university to the graduates. They don't have the money to incubate someone and incubate a startup as a type of investment. And even the scientific research in Egypt, scientific research funding in Egypt nowadays is going always toward what will be produced at the end of the research after 6 months or maybe maximum a year or two. So they want you to come up with something that they can sell in few months or in a year or two, which is not real science, of course. How do you get money out of such a system for startups to live on for maybe 4 or 5 years until they start reaching the break even? This is,
Yeah.
I have a startup myself, and I would love to get into this type of business, but I'm not looking at it because first of all, I need to get students interested in studying something that they can be hired for, not just out of mere scientific interest. So they need to see a future for. It is a good way in the university. This is actually what I do sometimes when I'm working on something new to commercialize. I started as a graduation project, and then I develop it into further graduate studies with the students that I pick up very selectively. But in that case, I and the students see the future of what we're doing. With quantum, the future seems to be uncertain and still far. And this is where you will fail to attract the students to get seriously into a startup.
Okay. Okay. Thank you, Dr. Ahmed, for the sharing. Actually, this make me going to my next question in the summit for Dr. Taha and Ahmed
I have a
Salim.
comment. I have a comment with
Yeah, sure.
for
Sure.
what يعني Dr. Ahmed he said. I agree with him that the problem of finding money is a great problem in Egypt. Even in ancient university, I tried to buy quantum lab, educational lab. Okay,
Mhm.
there is in Egypt a new company imported quantum Q-Sping or SQ-Bing, something like this. I
Okay.
didn't find enough money to buy this lab
Mhm.
for my students. This is really a great problem. Even ASRT recently announced a quantum network. But they put it a very difficult conditions to group a lot of persons as professors from universities to start the network. There is no flexible conditions to start this network.
Mhm.
We need really a good environment to start. But by any way, we will try. We will try to do something in this area,
Yeah,
inshallah.
inshallah. Yeah, that's what our community trying to help to build also an ecosystem here in Egypt in quantum computing.
Yes.
Actually, this take me to my next question to Dr. Taha and Engineer Ahmed. In the summit, I think there was several companies and research partner joined the summit in quantum computing and HPC. Which talk or demonstrations from industry partners stood out to you, and how do they reflect the direction of quantum technology in Europe? So we can start with Dr. Taha. Uh, can you hear me well? Do you want me to repeat? You are muted, Dr. Taha.
Yeah, okay.
Okay.
Yeah, sorry, can you repeat the question
Yeah,
again?
sure. In the summit, I think there was several companies and research partners joined the summit, talking about showcases advanced in quantum and high performance computing. So, which talks or demonstrations from the industry partner stood out to you, and how do you think they can reflect the direction of quantum technology in Europe?
That's a very good question. The first thing, impressive group of presentations is a session of the use cases. I mean, that's really pretty impressive because the teams also, there's like extensive collaboration between IBM and many research groups around the world, and they wanted to show how they are really using what is available now as a quantum hardware in real computations. Like how they can make the out of both the integration between the HPC and quantum hardware to deliver computation, for example, for the carbon dioxide, or making extreme expensive quantum chemistry computations, or even compute certain properties for biomolecules, or even do things in finance, like what Engineer Ahmed Salim has already mentioned, related to the SBC bank. So the use cases was a most prominent session in the summit for me. The second one is the Qiskit integration or the Qiskit architecture. How IBM wanted to deliver the quantum advantage next year, and they have outlined this. Of course, we know it because we already are technical persons, so we can understand how will be done. But they have outlined it for the lay person very clear, that they are gonna, since now there is a challenge to make chips with huge number of qubits that exceeds 120 qubits, for example, or 156 qubits. Then they are gonna do modular QPUs. So every QPU, every quantum processor will include this number, which is less than 200 qubits. And then with the error correction, that will act as 2 or 3 logical qubits, for example. And then they are going to stack all of this together, make a very optimized quantum network. So those are like networks that you can make a very nice microwave coupling, or you can use also optical fibers to enhance this. So there is a network that will couple all of these QPUs to deliver the what we are going to see later on as an abstract quantum computer. So you don't care what happens about this. You specify the number of qubits that you would like to integrate in your algorithm. You execute, but then the transpiler will tell, oh yeah, I have 10 QPUs. Everyone has 2 qubits, 2 logical qubits, because we have logical and physical qubits. The logical act like the perfect qubits. And the ratio between the logical and the physical determines the noise and the error that's happening. So there is now 20 logical qubits, and then if you decide to couple the first one with 20 qubit, they live in 2 different chips. However, because of the transpiler will do a very optimized way in order to make you execute the gate that requires the input and the output of the first and the 20th qubit, which lies in a different quantum processor. So that's the second one that stood for me. There is also a third one, is having very nice sessions and nice coffee, talk to people. But yeah, that's our what is the first one and two.
Okay. Thank you, Dr. Tao. What about you, Engineer Ahmed?
Uh,
What-
Definitely, I found it all very interesting.
Yeah,
But
good.
the one that attract my eyes, and I really find out the how the community can definitely make a difference, is the startup companies that publish their functions on top of IBM catalog. It's not about making money or delivering some facilities to be able to be in the quantum market. No, they developed a real useful functions that everyone can get benefits out of it. For example, Kidma, they give like a circuit functions that it can categorize the noisy operations which has errors, so it can do a categorization for these operations, and they can do later on error suppression and error mitigation based on these characterizations. So this is really a brilliant idea that can help IBM itself, or running any Qiskit on top of IBM, to be able to overcome the noisy systems. Um, uh, Q control as well, they develop optimization solver. So if you don't have any background on quantum, you can build a large scale, a utility scale problem definitely, and run it in the quantum machine. So all these functions will give you a very um, uh, close focus on how the community can definitely take the quantum to the next level, and emphasize it. If not IBM or any single vendor will be able to reach the top of this technology without having everyone building his own block and put it on one place to build this quantum system and make it useful to the humanity. So this is one of the amazing session that I can see these functions, these startups, how they are building their solutions, and everyone is getting benefits out of it. The problem that I can see, it's not a problem, but these functions, it's only available for the premium users on IBM. But I look into the other side, not a consumer, but as a creator. So
Yeah.
every and each one in this session, he might have an idea to add to the quantum ecosystem. He can develop his own function and publish it, and everyone will make use of it. If it's not taking it to the next level, definitely everyone will get benefits out of it.
Okay. That's wonderful. Thank you, Dr. Taha. Thank you, Engineer Ahmed. I think now we are open to questions. If anyone have questions about the summit, we can take like 5 minutes for the questions.
I have a question about the next meeting. It will be a monthly meeting.
Actually, yes, it will be like a monthly or bi-weekly.
It will be announced later. Yeah. Okay.
Yeah.
Right, of course. So I think this is the end of our session today. And I encourage everyone so to keep discussions more coming. You could join to our Egypt Quantum Computing community, where you will find more network and more discussions about quantum there. So feel free to join this through the link in the chat. So thank you very much. Thank you, Dr. Taha Salim. Thank you, Engineer Ahmed Salim, for this encouraging and this very useful session, and your thoughts actually it add a real value here. And also thank for all our attendees for being here today. So yeah, thank you.
Yes. Thank you, everyone. Thank you.
Thank you very much for having me in this session. And one more thing, I saw many familiar faces. Dr. Ahmad Musa, thank you for attending the session and enriching it with your comments. Dr. Wahid definitely is always adding value to any meeting. Thank you, Greg, for your comments, your question, your enriching the conversation. Dr. Asma, Salma, Mariam. So thank you very much for your time, and I hope that you find it of help.
And thank you all for
Thank you, Dr.
hosting.
Taha. Thank you, Dr. Ahmed. Thank you for all.
Thanks for you, Dr. Wahid, and I would like to thank Mohammed Fergani and Omar Sobhi for hosting, and also my co-speaker here, Engineer Ahmed Salim, and thanks for Greg and Dr. Ahmed Shawi Mousa, and also Dr. Wahid and the rest who have enriched us with questions. Yeah, and yeah, we look forward to see you on the future events.
Inshallah. Thank you, everyone. Inshallah, see you in our next episode in quantum industry. Yeah, we can end the meeting there.
Thank you. Bye.
Yeah, thanks.
Thank you.